Hey everybody, Mr. Field here. So today we're going to be talking about the three reciprocal trig functions. All right. So reciprocal, that term, this one right here, really just means essentially the flip. You may have heard this before in Algebra 1 when you're talking about parallel and perpendicular slopes like opposite reciprocal. So for instance, the reciprocal of something like, I don't know, 2/3 would be to flip it and say 3/2. That's reciprocal. So in terms of trigonometry, in terms of the three basic trigonometric functions, sine, cosine, and tangent, we also have these new ones over here, cosecant, secant, and cotangent. And you'll notice these are lined up for a reason. Sine and cosecant are the reciprocals of each other, just like cosine and secant are the reciprocals of each other, or the flip. And the same thing goes for tangent and cotangent. So this section hopefully is pretty easy. We realize that when we're thinking of so katoa, sine we know is so, or opposite side divided by the hypotenuse in a right triangle. So again, remember, all these relationships is really what they are. These trig functions are just a relationship between the sides and angles in right triangles. They're ratios. It's really all that's going on, a comparison of two numbers, or in this case, two sides and a right triangle. So sine itself is opposite over hypotenuse. So in order to find the cosecant of theta, this reference angle, the missing angle, well, we just need to take it and flip it. So instead of opposite over hypotenuse, we would now have hypotenuse over opposite. Simple as that. Cosine and secant are the reciprocals of each other. So since cosine is ka, and so katoa, we have adjacent over hypotenuse, we know that secant would just be the opposite, the flip. It would be hypotenuse over adjacent. And last but not least, we know tangent is toa, right? Opposite over adjacent. So that means cotangent would be the flip of that, adjacent over opposite. It's literally that simple. So we have 6 basic trig functions. At first there were 3. Now these are all 6 of them, the 6 basic trigonometric ratios. Sine, cosine, tangent, and then of course their reciprocals, cosecant, secant, and cotangent. So let's actually do this problem and see it in action. So one of the first skills you got to be able to do is obviously be able to, given a picture, right, given a diagram, be able to find the ratios, sine, cosine, tangent, and then of course their reciprocals. So let's start with sine. Again, here's our reference angle, theta. So we know that sine is going to be the opposite side. So the first thing we should always do is label. We know straight across, that's opposite. So I'm going to write OPP. We know across from the 90, that's hypotenuse. Then, of course, the other side is the adjacent side. So based on that, once we label the triangle, now we can actually write out the ratios. So I'm thinking that sine should be, in this case, opposite 5 over hypotenuse, 13. We do cosine. Well, we can realize that that's going to be adjacent, ka, so katoa. So adjacent over hypotenuse, so that should be 12 over 13. And finally, tangent should be opposite over adjacent, so I'm thinking 5 over 12. So that's what we've done so far. The new part, which I hope isn't too much of a stretch, is now we're just going to use the reciprocal property, or flip the fractions, and then we have all of our answers. Since sine is opposite over hypotenuse, or in this case, this scenario, 5 over 13, the cosecant would be the reciprocal of that, so 13 over 5. It's literally that simple. From there, cosine and secant are reciprocal. So since cosine in this scenario is 12 over 13, we know we'll have 13 over 12 for our secant ratio, which should be the flip, hypotenuse over adjacent instead of adjacent over hypotenuse. And last but not least, since tangent is opposite over adjacent, or in this scenario, 5 over 12, we can flip that and write the opposite, or the reciprocal, and say 12 over 5. So that's how you find the reciprocal properties for a given example. All right. Now, a little bonus off to the side before we forget. Just remember, when you're solving for missing sides, that's sometimes what you're looking for in a question, but sometimes you're also solving for the missing angle. So for instance, if we were looking at this problem at hand for this triangle, if it asked you what is theta, meaning what is that angle, we can actually use our calculators and these trig relationships, these trig ratios, in order to find that. And actually, you can use any of these 3 original trig ratios and your calculator, sine, cosine, or tangent, in order to find that missing angle by using the inverse sine. on your calculator. So notice for the first one, just to show you that it works either way, I chose to do sine. So I said this inverse sine of theta is equal to 5 over 13. Because remember, the calculator is only as smart as the user. So what I mean by that, one sec. And the calculator is only as smart as a user. When you type in, for instance, the sine of, I don't know, 30, and you enter that, the calculator is assuming that this is degrees. And of course, one more thing, let's check the mode to make sure it actually is in degree mode. And notice, it isn't. This is one big important piece of information. When you're using your calculator, you got to make sure you hit the mode button and first change it to degrees. So notice mine's in radians, and we're going to talk about what that means in just a few chapters here. But for now, we're going to be working with degrees. So we've got to make sure we're in degree mode. Again, the calculator is only as smart as a user, so it needs to know what we're talking about here. It needs to know that, hey, when I enter sine of 30, it means sine of 30 degrees. So in other words, when I enter the angle, it should spit out the decimal version. The ratio between the sides would be, in this case, 1 over 2, 1/2 of the sine of 30, which of course as a decimal is 0.5. So when I type in sine of 30, it knows that that's sine of 30 degrees. If you're doing the opposite though, which is what we're doing in this case, right? We're saying, hey, we don't know the angle, but we do know the relationship between the two sides. You need to tell the calculator that. You need to say, hey, we're looking for the angle. So when I type in sine of 30, that's saying sine of 30 degrees. That spits out the relationship between the two sides. But when you're plugging in the relationship between the two sides, in this case 5 over 13, we have to tell the calculator that. So I have to hit second sine, and then I can say simply 5 divided by 13. I'm going to close that parentheses, and of course that should spit out the angle measure now. So again, the calculator is only smart as a user. You got to make sure you tell the calculator what you want. Looks like we get 22.619, so about 22.6 degrees. Now keep in mind, you could do this for either of these three relationships, right? Sine, cosine, or tangent. I just happen to choose to use sine and tangent just to show you that we should get the same answer. So again, if I do second tangent, remember I'm doing second tangent because I'm telling the calculator, hey, this is not a 5, for instance, the last one, a 5 divided by 13 degree angle, right? That's the relationship, the ratio between the two sides. So in this case, I'm saying, hey, the relationship between the two sides, a tangent relationship, is 5 to 12. And then it should spit out the angle, and again, notice it's the same angle. And since we're talking about the same reference angle, the same theta in this picture, we should end up getting the same answer. So just throwing it out there, you actually can solve for, once you know the trig ratios, you can solve for the missing angle as well as any missing sides if there happen to be any. So let's do a couple of examples, and let's see what we come up with. All right? So first thing I want to do, just find the value of the trig function indicated. So we're looking for the secant of theta. So the first thing I'm going to say and realize is that that's a reciprocal function. It's not one of the originals. So if I look back to my reference list, I know that secant is the reciprocal of cosine. And since cosine is adjacent over hypotenuse, I know that the secant of our missing angle would have to be, instead of cosine being right, adjacent over hypotenuse, we should have hypotenuse over adjacent. So based on that, I'm thinking the secant of theta for this example is going to be, again, this is the opposite. You can always label the side. So O, H, A. I'm thinking we're going to have hype, H, 5 in this case, over adjacent, 3. And that would be your answer for this problem. All right? So hopefully it's not that bad. So one more, given the cotangent of theta. Well, again, cotangent should be the opposite of tangent. And again, if it helps, you can always write it down. Since tangent is OA, opposite over adjacent, we know cotangent should really be adjacent over opposite. So again, I'm going to label the sides opposite, adjacent, hypotenuse. Toe would be 8 over 6, so our answer should be 6 over 8. Now, here's a little bit of a point of contention. Some teachers would ask that you simplify that fraction. For me, personally, I don't mind that you write just 6 over 8, but some would ask that you actually simplify that to 3/4. But for me, I'm totally cool with 6 over 8. So just throwing that out there. Pardon. All right, last couple examples real quick. So now we're given two sides of the triangle, and we're looking for theta. So it's wondering what is the cosecant of theta. So again, we can always go back to sine, cosine, tangent. I know cosecant is the opposite of sine. So for instance, I know the sine of theta is supposed to be the opposite over hypotenuse. Again, I'm going to label the triangle and kind of just take stock of what I've got. Based on theta, if we follow the arrows, and it's kind of a tiny triangle, I believe this is the opposite side, this is the adjacent side, and this is the hypotenuse. So we have a little bit of a dilemma. If we can figure out what opposite and hypotenuse are, then all we have to do is flip them, right? Use the reciprocal property, and we'll have our answer for cosecant because it's the flip. However, we have a small dilemma. We know what the h is, so I know that I can plug in 25. However, at the moment, we don't know what cosecant is, or sorry, pardon me, what the opposite side is. Getting ahead of myself. So we have to figure out a plan for how we can solve for this missing side. We got to solve for O. Well, again, we've talked about several different possibilities here. We know this is a right triangle, and when you're solving for a missing side, when in doubt, you can always go back to the Pythagorean theorem, or maybe it's a special right triangle, and you can apply one of those properties as well. So these are like little puzzles that you're going to use, whatever information you're given, to solve for whatever's missing. So in this case, I'm going to go ahead, instead of O, I'm going to call this side X, that's what we're looking for. And I realize that this is a right triangle. We are given 2 of the 3 sides, so Pythagorean theorem is an option. I can say x squared plus 7 squared, which is 49, by the way, is equal to 25 squared, which should be 625, if I'm not mistaken. From there, I'm going to subtract 49 from both sides. Get x squared equals, well, let's see, 625 divided by, oops, pardon me, 625 subtracted 49, 576, and then of course we're going to take the square root of that. And that should give us our answer, in this case, 24. Remember, whatever we do to one side to the other, the opposite is squaring and square rooting. So we should get x equals 24. And really quick, we can do a quick discount double check here. We know that our answer better be smaller than 25. Why is that? You guessed it, the hypotenuse is always the long side in a right triangle. So I'd like you to try the next couple of questions, right, in order to answer the question. And I guess, actually, Mr. Field, come on. I didn't actually answer the question. Now that we know that x is 24, we know the opposite side is 24. So now I have officially got sine. So in order to get my final answer, I would simply flip it. So it looks like the cosecant of our mystery angle is going to be 25 over 24, final answer. Woo, man. Don't do what I just did. Make sure you always answer the final question. So I'd like you guys to try 4, 5, 6. Take a minute, see what you can do. And then, of course, there'll be a little more practice after this. Hope this video was helpful. Thanks for watching.